you have your output for characteristic equation. We need to make a truth table in this fashion. This fashion means your output, that is the next state of the flip flop, depends upon the control input of S R. Of course clock is there, we are not mentioning that. It depends upon the input of S and R, and it depends upon the history of your present state. So S and R are your inputs, and this is your present state. P underscore S is present state, and Q plus is what? Next state. N underscore S is next state. So you know that your next state depends upon SR input, and also it depends upon the present state Q. Okay. Now the way you used to make truth table, you should make in that fashion only. You have to take this as a 3 variable function, 3 variable input. So your Q plus will be function of S, R and Q. With this we will get the characteristic equation. Why it is important? It is important because you will be making various synchronous and asynchronous counter, designing it. So that time this characteristic equation and this table what I am making is very important. You will be making elaborate tables of next state based upon present state and input there. So we have to make this truth table now, and truth table of 3 variable means what? It will have all the possible cases. And how many possible cases are there? How many possible cases are there with 3 variable?
9, ma'am.
8.
Correct, 8. So let us make those 8 cases. Okay, so it is okay. My 8 cases are ready. It became little dirty. You people make it neat and clean. So you can see that I have my 8 cases, right? So 000 to 111. I have my 8 cases. So now you have to tell me quickly. Okay, 2, 3 of you can unmute yourself and tell me quickly. If S and R are 0 and 0 and present state is Q, what should be the next state? S
It will
and
be Q
R.
only. It will be Q only.
Q only. And what is my Q? Q is 0. So it
0.
will be 0, right? So
Yes,
S
ma'am.
and R are memory state. So whatever is present state, the same will be next state. So when it was 0, it will remain 0. When it was 1, it will remain 1. So I have got my 2 possibilities of memory state. Now let us see this one, the third and fourth row. It is a reset case, right? Reset means it will not depend upon input, and what will be the output?
0.
Yes. So third and fourth row, it will be 0. Good. It will be 0. Now, fifth and sixth row, it is fifth
Set
and
state.
yes, it is a set state, right? So it is set state means output will be
1.
1 and 1. So I got my output as 1 and 1. And what about this second last and last row? It is a,
Ma'am, you can't predict that. It's an indeterminate state.
yes, it is a invalid state, indeterminate state. So that is why we will put a dash here, because that we don't know. So it may go as a don't care there. Okay. Now let us make an equation for it. So what do we do for that? We make a K map. I hope you people have not forgotten your K map. So K map, and your input will be like your, it will be written in the form of your equations, your K cell map, and it will be SRQ, right? SRQ. So quickly all of you make this, and it will be 1 for what, which all cases? So it is a 0, 1, 2, 3, 4, 5, 6 and 7. And this is 1 for which all case? It is 1 for 1, 4, and 5, right? 1, 4, and 5. So it is 1, 4, and 5, right? Any doubt in this? And you should also make your don't care. Don't care means it is 6 and 7 is your don't care. So we will make don't care of 6 and 7. You can put a dash, but you are in habit of making cross, so we are making it cross. Okay, so this is a don't care. These two are don't care. So now when we make the grouping, what you will get? One is this, right? And one is this, right? And this is 0, 1.
S plus R bar Q.
S plus R bar Q. Very good. So your Q plus is this row. This row will give you S, right? So S plus. And what this column will give you? It is R bar Q. R is 0, Q is 1. So this will give you R bar Q. So this becomes your characteristic equation of SR flip-flop. I hope it is clear to all of you. It will become the characteristic equation of SR flip-flop. Now quickly let us go to next flip-flop, that is your D flip-flop. Why I am in hurry to go to D flip-flop? Because everything is so concise and small for D flip-flop. So what do we see in D flip-flop? Because it is only one input, it will have D here and it will have a Q and output is your Q plus. So D is your input. Okay, I will, all of you can do it on your own and give me the answer before I complete it. D is input, Q is present state and Q plus is next state. Okay, this red color has become font less. Please understand. D is input, Q is present state and Q plus is next state. Okay, now you know that it is a 2 input, 1 output case. 2 input, 1 output case. So what is the, how many possibilities will be there? Because it is only 2 input, I will have only 4 possibilities. So I have written on all my possibilities here, right? And now let us write the output. Yes, now you will have to tell me. If D is equal to 0, Q is 0, what is the output here? If D is equal to 0 and Q equal to 0, what should be the output?
Don't care.
No, you remember when I say Q will
D flip flop only the middle two rows will be active, right?
Is it 0, ma'am?
it will be 0. See what happens, no? If D is 0, Q is 0. So in the next clock cycle, when the clock pulse come, your output will become equal to input. Okay. And you remember that when output is equal to input, your present state actually does not matter. Okay. Remember your D flip-flop. When output becomes equal to input, Q plus is equal to D, your output, present state does not matter only. So your output simply follows your D. So the full truth table will look like Q plus is equal to D and your present state does not matter only. So do I need to make a K-map for this?
No, ma'am.
We can simply write Q plus is equal to D like this. Why it is happening? Because present state does not alter your next state of D. That is why D flip-flop is the most commonly used for registers, and many a times we will be using it for making an easy counter. You will see that the design's procedure will be very concise and small for your D flip-flop. Okay. Now T flip-flop is not that very straightforward. You will have to make a table for it, or you can do it with your aptitude also without doing making K-map also. Let us see. So T flip-flop, how many inputs? Again, it has two input only, toggle input and present state, and this is your next state, right? So I am writing again. Okay, you people can quickly tell me before I complete. So T is your input, Q is your present state, and Q plus is your next state. Okay. Now let us start with our two. It is two input means only four variables will be there. So 0, 0, 0, 1, 1, 0, 1, 1. Four possibilities have come. Right. Now, please let me know what will be the output. When toggle input is 0, it will behave as, if toggle input is 0, it will behave as,
Memory state.
yeah, right, very good. It will behave as memory state. If toggle input is 0, it behaves as memory state. So next state becomes equal to present state. So it will simply copy the present state to the next state. If toggle input is 0, memory makes present state equal to next state. Okay. Now when toggle is 1, what happens? Toggling happens. So if present state is 0, next state will become
1, ma'am.
correct. If present state is 0, next state will become 1. And if present state is 1, next state will become 0.
0.
Okay. Now, can you tell me the equation without making K-map? Who will make K-map for such small truth table? It is nothing but a which gate? See, making an equation from truth table means what? We have to select where it is 1. We have to select where it is 1.
XOR gate, ma'am.
Yeah, right. So when I see it is 1 for two possibilities. For the first possibility, T is 0, Q is 1. So it becomes T bar Q. It becomes T bar Q. For the next row of 1 output, it is T equal to 1, Q equal to 0. So it becomes T Q bar. You will get the same terms even if you make a K map. Okay. Now we can either write it as T bar Q plus TQ bar, or we can also write as it is nothing but XOR version of T and Q. T and Q input as this. Okay. So this is your characteristic equation of T flip-flop. Okay. Now let us do the next one, the last one, that is your JK flip-flop. Now you people know that what is the procedure, right? So you should be able to do it on your own now. Okay. So fourth one is your JK flip-flop. Now I want you people to do this also, and question related to this is posted in Google Classroom. You should answer that also. Okay. So quickly I will do it here. I hope you all know what you are doing now. It is J, K, Q and Q plus, right? So this is all input and this is your output, right? All of you do it. You need not wait for me. So how many possibilities will be there? All are busy doing or what?
8 possibilities, ma'am.
Yeah. So 0 1 0 1 0 1. I have got this. Then 1 1 0 0. Right now you should tell me. You should tell me the outputs. When J and K are 0 and 0, first row and second row is which case?
Memory state, ma'am. We'll get same as Q.
Yes, J and K is memory state. So you will simply get your Q plus as equal to Q. So it will be 1 and 1. I hope you people remember something which I told during teaching JK flip-flop is what? Q follows J if J and K are different. Q follows J if K, it is just a way of remembering. Okay. So J and K, when it is 0 and 1, it is actually a reset case. We do not call it reset and all. Why? Because it is not a SR flip flop. S and R is for set reset flip flop. SR full form is set reset flip flop. But when I say 0 1, I should not call it as reset and 1 0 as set. So we simply say that it is following, output is following J. So actually it is similar to reset. So your output becomes 0 and 0. And you can see input is also 0 and 0. So that is why your output becomes 0 and
0
0.
0.
That is nothing but following J. Can you see? It is following J. Now same way, now you can see the other one. Next one. Next one says 1 0. That, as you know, in SR it is a set case. Set case means output becomes 1 irrespective of whatever is your input. So it will become 1 and 1. And you can also see again it is following J. 0 0 1 1 0 0 1 1. It is following J. So from here to here it is following J. Okay, I will write here also. It is following J input. Okay. Now, what about this last two case? When J and K both are 1?
It will be 1 0, ma'am.
Yes, it is a toggle state. So 0 becomes 1, 1 becomes 0. So present state 0 toggles to 1, present state 1 toggles to 0. So this is my truth table. Now quickly you should be able to make K map of it. Okay. Actually speaking, I should have given it to you only to do, but just for the completeness of our recorded lecture also, I will make it as complete and do it. Okay. So you people can quickly tell me the answer before I complete. It should be one for which all cells. So it is for 1, right?
Ma'am, it is J Q bar plus K bar Q.
Yeah, right. Okay, let me complete it for all others. So it is, which all cell is 1? Tell me. 1 is there, then 4, 5, 6, right? 1, 4, 5, 6. So 1, 4, 5, 6. Right? So we can see that okay, so tell me. Right? One pair, next pair. So Q plus becomes, for this one, these two, what I am getting is J, J and Q bar. So J Q bar. And what is the other one? This is K bar Q, right? This is what he gave the answer. So you have JQ bar and K bar Q. So this is your characteristic equation of JK flip-flop, right? Okay, all of you understood the characteristic equation for all the 4 flip-flops. JK is there on your screen, and SR, D and T was done previous to this. Okay, any doubt for the characteristic equation?
No, ma'am, no doubt.
Yeah, okay, good.